All right, so here are the solutions to the 6.2 homework. Kind of carries on a lot from what you would have seen in 6.1. So we're going to do a lot of discussing increasing, decreasing, where we have a maximum, where we have a minimum, what the maximum is, what the minimum is. Again, the book tends to ask for extreme points. I will literally never ask you for extreme points. I will only ask you for the extreme value separate from the critical value. All right, so number one, they gave us the sign pattern of f prime and wanted to know where f was increasing. Well, if our derivative is positive, our original function increases, so I know that I'm increasing from negative 3 to 0, 3 to infinity. And again, I'm using parentheses, not brackets, because at negative 3, 0, and 3, plus or minus 3, 0, f is stopped. In other words, we potentially have a maximum or a minimum. Number two, not that different. This time they use g prime. Again, they want to talk about where g increases, so I want to look for where the derivative is positive. Oh, sorry, my mistake. They wanted to know where it was negative. Let me fix that, right? So they want to know where the graph is decreasing, so I look where my derivative is negative. Now, again, I've got to break the value up at 2. I break at x equals 2 because the derivative is 0, that our function has stopped. All right. Number 3 asks us a couple different questions. In part A, it wants to know where we have a maximum. We have a maximum when our sign pattern of the derivative changes from positive to negative at a 0, and that happens at negative 4. So again, because the derivative changed from positive to negative as we crossed the boundary at negative 4, I know that the original function would have a maximum. Whether it's an absolute max or a relative max is something I would have to determine later. With that same thing in mind, I know that I don't have a maximum and I don't have a minimum at negative 1, because as I cross that boundary of negative 1, my sign doesn't change. It stays negative to the left and negative to the right. What we would say is at x equals negative 1, we have a stationary point. An easy example of this is if you think of x cubed just kind of has this funny little spot at 0, 0. Well, x cubed is stationary there, but does not have a maximum and does not have a minimum. So number 4, again, we've got a sign pattern. This time it looks like they're asking for a minimum. So I know that I want my sign pattern to change from negative to positive. So I've got a minimum at negative 2 because f prime changes from negative to positive. Number 5, very similar to a question we answered earlier. We want to talk about where the original function is decreasing. So I need my derivative to be negative. But again, notice at negative 3, I've got to break my intervals up because at negative 3, g has stopped. Now, the rest of the problems really are going to analyze what we have in the exact same way. It's just going to be a matter of us needing to find the sign pattern ourselves and then work from it. So if I want to talk about my original function increasing, my original function decreasing, where I might have a maximum, where I might have a minimum, I need my derivative set equal to 0. This one's not factorable, so I used my calculator to come up with the 2 critical values. I know these are my critical values. I made a sign pattern of my derivative, and if I'm making a sign pattern of the derivative, remember I'm testing values in the derivative. So by the time I finish my sign pattern, I can see that my sign pattern of the derivative is positive on the left, positive on the right. So I know my original function would increase negative infinity to 0.131 in union with 2.535 on to infinity. 12 is very similar. I need to find my derivative. I need to set it equal to 0. This one did not end up being factorable, so I had to use my calculator to get my critical values. Again, if I'm making a sign pattern of the derivative, I'm testing in the derivative. Once I have my signs, the question we were asked is, where is our function decreasing? Our function decreases when the derivative is negative, so my interval is negative infinity to negative 4 in union with negative 1 to 2. Now 15 is the same function as number 7, so I just went ahead and took my sign pattern from number 7. So I know my 2 critical values. The values that make my derivative equal 0 are my critical values. I have my sign pattern. And then if I'm looking for a maximum, I know I want the derivative to go from positive to negative, and that happens at 0.131. If I'm looking for a minimum, I want my derivative to go from negative to positive, and that happens at 2.535. Now, again, these are not the max and min, they are the location of the maximum and minimum. It'd be like asking the question, where is the tallest building in the world versus how tall is the tallest building in the world? They're related to one another, but they are different questions with different answers. 20 used the problem from number 12, so I just took my CVs, took my sign pattern, and again, I know I want minimums when the derivative changes negative to positive, and that happens at -4, that happens at 2. If I want maximums, I want my derivative to go positive to negative, and that happens at -1. And again, these are not the maxes and mins, they are the location of the maxes and mins. If I wanted to know whether they relative maxes, relative mins, absolute maxes, absolute mins, I'd have to start plugging into my function and looking at what we're going to call end behavior. Now, 24 is really asking you to extend your idea of what you're thinking. In 24, it says, where do we have a relative maximum of velocity? Well, if we're looking for a maximum, we want the derivative of velocity to change from positive to negative. Well, what is the derivative of velocity? Acceleration is the derivative of velocity. So I set acceleration equal to 0. I get the critical values of velocity. I make a sign pattern of acceleration, or what you could call the sign pattern of v prime. And I see that I have a maximum when my sign changes positive to negative. That happens at -2. Now the question is, what is that maximum? So I have to plug -2 back in, and 1200 is the maximum. In B, it wants to talk about the minimum of and maximum of acceleration. And again, if I want to talk about the minimum or maximum of something, I want to look at that something's derivative. I set that thing's derivative equal to 0, solve, make my sign pattern. Now I know that I have a minimum because the derivative of acceleration changes from negative to positive. Since my sign pattern doesn't change from positive to negative anywhere, there would be no maximum. The acceleration is going to go up forever. All right, hopefully that helps. This is some important stuff. These are questions that you're going to be answering literally next year when you take your AP test. So if you have any questions that weren't cleared up by the video, make sure you ask in class.